Let's say you're working out a problem. At the very end, you have this situation where you have a fraction times x is equal to another fraction. Whenever you have this sort of situation, what you need to do is multiply both the left-hand side and the right-hand side by the reciprocal of the fraction that's with the x. So if I just rewrite this expression, or rewrite this equation, we have this as my problem. To get the x by itself, what you need to do is multiply the left and the right hand side by the reciprocal, which is this fraction, flipped around. So we're multiplying the left and the right hand side by 3 over 2 instead of 2 over 3. The reason we do that is because on the left hand side, these fractions will actually cancel out. Like if you think about 3 times 2, that's 6. 2 times 3 is 6. So we would end up with a fraction of 6 over 6. And 6 divided by 6 is really a 1. So all of this would become a 1, and the x would be next to it. What does 1x become? 1x becomes just x. So our goal was to get rid of this fraction, and we do that by multiplying it by the reciprocals. So we write it out like this, and we can just cross out the 2's and the 3's. From here, we can simplify the right-hand side by doing the multiplication. And in this case, we can just because they're fractions that are being multiplied, we multiply the numbers from left to right. So 1 times 3 gives me 3, and 4 times 2 gives me a final answer of 3 over 8. If we do one more example of this situation, let's say we have 1 over 5x equals 2 over 3. Again, x is being multiplied by a fraction. To get rid of that fraction, we need to multiply the left-hand side by the reciprocal of 1 over 5, which is 5 over 1. Because we did that on the left side, we need to do it on the right side too. So on the left-hand side of the equation, everything's going to cancel out. The 5's are going to go away, the 1's are going to go away, and it'll leave me with an x. Now on the right-hand side, it's just a matter of doing the math. A fraction times a fraction, you multiply the numerators together and the denominators together. 2 times 5 gives me 10, 3 times 1 gives me a 3, and we're left with this final answer of 10 over 3. Now for some problems, you're going to have x being multiplied by a fraction, but instead of it being equal to a fraction, it's going to be equal to a whole number. So I'll go over this example right now. When you have this sort of thing happening, it's very similar to working with fractions. So we're going to take both sides of this equation, and we're going to get rid of this 4 over 3 by multiplying them by its reciprocal. So if I copy down the problem as it is, this is what we have, but I'm going to take both the left and the right side, and I'm going to multiply it by 3 over 4. Because I want to get rid of this 4 over 3. When I do that on the left side, everything cancels out except for the x, right? The x is still here. But on the right hand side, you end up getting a whole number times a fraction. Now you should be able to do this, but in case you are struggling with it, the only thing we need to do is place that 2 over a 1. You can rewrite 2 as 2 over 1. So now we have 2 over 1 times 3 over 4, and it's just a matter of multiplying the fractions from left to right. 2 times 3 is 6, 1 times 4 is 4. Now the only issue with this answer is it's not simplified all the way. If we simplify it, you need to figure out what number goes into the 4 and the 6. That would be a 2. How many times does the 2 go into 6? It goes into 6 3 times, and 2 goes into 4 2 times. So my final answer ends up being 3 over 2. But the key thing for this problem is if you have a whole number and you're multiplying both sides by a fraction, turn this whole number into a fraction by placing it over a 1 and go from there. I'll do one quick example that's pretty much identical to the other one. We have 6 over 5x equals 5. First thing I'm going to do is put that 5 over 1. Then I'm going to multiply both the left and the right side by the reciprocal of this fraction that's with the x, because we want to get rid of it. So we're going to multiply by 5 over 6, and we're going to multiply the right by 5 over 6. On the left hand side, everything crosses out except for the x. On the right hand side, we get 5 times 5, which is 25, over 1 times 6, which is 6. And this ends up being my answer. Okay, so another last step situation is when x is being multiplied by a constant. You could think of the constant like being a whole number. So when the x is being multiplied by a constant and is equal to a fraction. So this situation right here. Similar to what we just finished doing, anytime we're dealing with fractions, it's usually a good idea to make everything into a fraction. And that's exactly what we want to do in this problem. So we have 2x equals 2 over 3. Because we have this fraction, I want to make my 2 into a fraction before I do anything. I don't want to divide both sides by 2 like this, because this is already a fraction. Okay, and that's the only reason we're not dividing by 2. So what I can do instead is I can rewrite this 2 as a 2 over 1. And so I can treat that 2 as a 2 over 1. And now this is a situation similar to the last examples that I just finished doing. To get the x by itself in these situations, we take the reciprocal of this fraction. So we take that fraction and we flip it around. So we would write it as 1 over 2. And we would multiply it to both the left side and the right side. Now on the left side, even though we are multiplying them, they end up canceling out. The 2's go away and the 1's cancel out. This leaves me with x is equal to whatever the right hand side is. Now we just need to multiply the right hand side. 2 times 2 is 2. 3 times 2 is 6. And this would give me a final answer of 1 over 3. One more example of the same situation. I would recommend you do it first and then continue the video to find the answer. X is being multiplied by 7 and it's equal to a fraction. So we want to turn that 7 into a fraction. We can turn it into a 7 over 1 and leave everything else alone for now. So that's my first step. The second step, to get rid of that fraction. And we can do that by multiplying both the left and the right hand side by the reciprocal of 7 over 1, which is 1 over 7. So if we do that, the 7's go away on the left side and the 1's go away. It leaves me with the x. And on the right hand side, we get 1 times 1 in the numerator, which is a 1, and 4 times 7 in the denominator, which is a 28. So my final answer ends up being x equals 1 over 28. So this next one can be a little confusing because there's no symbols besides the equal sign. And this is when you have x times a constant, in this case 3 times x, is equal to another x, so it's equal to 2x. Notice that there's no plus, like there's no plus 5, there's no minus 5, there's no divided by 2 or anything like that. So these can be really confusing. What we don't want to do in these situations is divide by 3, because then we'll be left with x equals 2 over 3x. But our goal is to combine the x's, right? That's the whole goal of solving equations, is getting that one variable by itself. But we have 2 variables. So the way it works is we actually want to add or subtract 2x or 3x. It doesn't matter which one we move, but our goal is to move this term to the left side or move the 3x to the right side. And again, it can be a little confusing, but all we need to do is either add or subtract it. The problem is we don't want to plus 2x, because then we get a 4x out of that, and we don't want to come up with more x's than we already have. We're trying to get rid of either the 2x or the 3x. I'm going to get rid of the 2x. So think of that as being just the number 2. How do you get rid of the number 2? You don't multiply it by anything, or I guess you can multiply by 0, but you really want to subtract. So we're going to subtract 2. Not just 2, but 2x. Now what I do to one side, I do to the other side. So we're actually going to subtract 2x from the left side too. If you think about what's going on, 2x minus 2x really gives me a 0. Right? 2 minus 2 would give me 0. So 2x minus 2x gives me 0. On the left hand side, we have 3x minus 2x. And 3 minus 2 is 1, which would leave us with 1x, or just x. So for this problem, we actually end up getting this answer of x equals 0. And I do think this is one of the most confusing examples that we're going to come across. But it'll actually be pretty common. You're going to see this a lot. So hopefully this makes sense. But there's no plus or minus signs on any one of these sides. And it's kind of memorization. You got to think about what you can do. And in this case, it's subtract 2x. If instead we would have did 3x equals 2x and subtract 3x, we would end up with the same answer. If we decided to subtract 3x from both sides, 3x minus 3x gives me a 0. On the other side, 2 minus 3x gives me a negative 1x. And if 0 equals negative x, then positive x would give me 0. Anyways, let's do another problem similar to this. We have 5x equals x, so they're both x's. Just based on this last example, we know that we either need to add or subtract 5x or add or subtract x. It doesn't necessarily matter which way you do it. I usually go with the smaller number, so this 1x, you could think of it as being a 1x. We're going to subtract this x from both sides. On the right hand side, x minus x gives me a 0. On the left hand side, you have 5x minus x, or 5x minus, you could think of that as a 1x. So 5x minus 1x gives me a 4x, so we have 4x equals 0. From this point, we can get the x by itself. It doesn't matter what's on the right side. Think about what's happening to x. X is being multiplied by 4, so we end up dividing both sides by 4. This leaves me with x equals whatever 0 divided by 4 is, which is just 0. Okay, so I believe this is the last set of problems that I have. And this is a situation in which x is being added or subtracted on both sides of the equal sign. So in this case, you see an equal sign and we see an x on both the left side and the right hand side. So in these situations, you want to do the opposite to both sides. You want to look at each side of the problem and then just move the numbers around by doing the opposites. So it doesn't matter which side you start on. I just tend to start on the left side. X is being added to 2. So let's say I want to get this x by itself. What's the opposite of adding 2? Subtracting 2. So I subtract 2 from the left hand side, and on the right hand side, I need to put a minus 2 as well. Now I don't want to write it here because we don't know what x is, so we don't want to subtract 2 from the x. Instead, we write it under the 3. We put a minus 2 underneath the 3 because they're both numbers. If we simplify everything, 2 minus 2 gives me a 0, so we can just cross those out, and it leaves me with an x. We have an equal sign, so I can copy the equal sign down. On the right side, we still have a negative x. And now we have whatever 3 minus 2 is. And 3 minus 2 is a positive 1. So we're going to write a plus 1 to represent that positive 1. Okay, so at this point, we do need to get the x's on the same side of the equal sign. So I want to move this the x on the right hand side, I want to move it to the left. I want to move this over here. Now how do I do that? We do it by doing the opposite operation. You could think of this as a minus. Right now it's a minus x. What's the opposite of minus, or what's the opposite of subtracting x? That would be adding x. So we actually want to add x to both sides of the equation. On the right hand side, negative x plus x, those are opposites, so they actually cancel out, and it leaves me with the 1 that's on the right hand side. Now on the left hand side, we have x plus x, and x plus x is really 2x. At this point, we're almost done, but the x still isn't by itself. It has a 2 attached to it. 2x is the same as 2 times x. So right now, x is being multiplied by 2. Opposite of multiplying by 2 is dividing by 2. So we need to divide both the left and the right hand side by 2. This leaves me with the final answer of x equals 1 over 2, or 1/2. For this example, we're going to do it the same way. We can focus on the left-hand side first. So first off, we have x's on both the left and right-hand side. We want to move the x's together, but we always want to move the numbers together too. So x is being subtracted by 1, which means we can add 1 to both the left and the right-hand side. On the left side, that ones go away. It leaves me with x equals x plus 2. So we combine the numbers, but now we need to combine the x's. I need to move this x to the left-hand side. To do that, think about, ignore the 2. The 2 almost doesn't matter. How do I get rid of an x? I get rid of that x by subtracting x from it. So I subtract x from both sides. And it's going to leave me with an unusual answer, but that's okay. X minus x on the right hand side, they go away. They give you 0. On the left hand side, x minus x, they go away too, but it leaves me with a number. I need to write some number down. So what's x minus x? That's really a 0. On the right hand side, we still have this 2. So for this problem, it's intentionally weird in the sense that we get this expression that says the number 0 is equal to the number 2. Now that idea, 0 equals 2, it doesn't make any sense. In math, we call that a contradiction. This actually has no solution. So my answer ends up not being x equals something. My answer literally becomes no solution. There is no proper answer to this problem. And the last unique example is when we have an expression equal to itself. So let's ignore the right hand side. Let's pretend we're trying to get x by itself. The first thing we need to do is subtract 4. And what we do to the left side, we do to the right side. So the 4's cancel out. It leaves me with x. On the right hand side, 4 minus 4 gives me 0. So those cancel out too. And it leaves me with x. So we're left with x equals x. And just like before, the way that we get rid of the x is by subtracting it. When nothing else is happening to the x, we just subtract x from both sides. Now we end up with this unique situation where we have x minus x, which is 0. And on the right hand side, we have x minus x, which is also 0. So we end up getting 0 equals 0. And that's a true statement, right? That always makes sense. The number 0 is equal to the number 0. So for this type of problem, we actually say that it's always true, and it's true for all real numbers. So my final answer would actually be all real numbers. Which at this point in the class, it's a little unusual to see that, and you're not going to see that anytime soon. But all real numbers, that's just saying that this equation is always true. It doesn't matter what x is. All right, you can think of any x value. If you think of any x value and you put it into this equation, the left-hand side will always be equal to the right-hand side. And that's what this all real numbers means. That's what it represents. And if we go back and look at it, it makes sense. It's saying that a number, right, x plus 4, is equal to x plus 4. The number is equal to itself, which makes sense. But that means that there won't be an x equals something, right? We won't have that as an answer. Instead, this equation is true for all real numbers of x.